Brain knows it's not dangerous. Brain has looked it up. Brain has run the numbers. Brain has had the rational conversation with itself approximately 47 times. The spider in the corner is tiny. The dog across the street is on a leash. The turbulence on the plane is normal. The needle is just a needle. The darkness is just the absence of light. Brain knows this. Brain can explain this. Brain can write a whole essay about this. And then brain sees the thing and completely loses its mind anyway. Heart pounding, palms sweating, legs deciding to leave without asking, entire nervous system treating a house spider like it personally threatened brain's family. And the most embarrassing part? Brain knows it's irrational. Brain knows it's fine. Brain knows. And it doesn't matter. Not even a little. Today, Brain is going to find out why logic is completely useless against certain fears, what is actually happening inside Brain when it encounters something harmless and responds like it's the end of the world, and what Brain can actually do about it, because telling yourself to calm down has never once worked, and Brain is going to find out why. Inside Brain, there are two systems running at the same time. System 1, the fast system. This is Brain's ancient emergency response. It has been running for hundreds of thousands of years. It does not think. It does not analyze. It does not ask questions. It just reacts. Something appears. Fast system scans it in milliseconds. Danger, run, fight, freeze. Not danger, carry on. The whole process takes less time than Brain can consciously register. System 2, the slow system. This is the rational brain, the thinking brain. The let me evaluate the actual risk brain. This system is thoughtful, logical, nuanced, accurate. It is also very slow. By the time the slow system has finished its careful, sensible analysis, the fast system has already activated every alarm in the building, flooded the body with adrenaline, and redirected blood to the legs in case Brain needs to run. The slow system arrives at the scene, surveys the chaos, and says politely, "Actually, it was just a spider." Too late. Brain is already halfway out the door. This is why logic doesn't stop fear, because by the time logic arrives, the fear is already done. The rational mind and the survival system are not in a debate. They are in different races, and the survival system always wins, because it started first. Inside Brain lives a small structure called the amygdala. The amygdala is approximately the size of an almond. It has the personality of an extremely anxious security guard who has never taken a day off and does not trust anyone. The amygdala's entire job, its only job, is to scan for threats. Every second, every moment, every room Brain walks into, every sound Brain hears, every shape Brain sees. The amygdala is checking, always checking. And the moment the amygdala decides something is a threat, it does not send a polite message to the rational brain for a second opinion. It bypasses everything, directly, immediately. Adrenaline released, heart rate up, breathing accelerated, muscles tensed, digestion paused. Brain doesn't need to digest food if it's about to be eaten. All of this happens before Brain even consciously sees what it is looking at. Studies have shown that the human brain detects spiders and snakes faster than it detects flowers or butterflies, even when the images are shown so briefly that the person isn't even sure they saw anything. The amygdala saw it. The amygdala always sees it. The amygdala does not need Brain's permission. Brain is not afraid of the spider. The amygdala is afraid of the spider, and the amygdala does not care what Brain thinks about that. Here is the question Brain actually needs answered. Why is the amygdala afraid of a spider that poses zero real threat? Why does turbulence on a plane trigger the same response as actual mortal danger? Why does a dog on a leash make Brain's body react as if the leash might not be real? The answer is one word: evolution. Brain's amygdala was built not for the world Brain lives in now, but for the world Brain's ancestors lived in 50,000 years ago. In that world, spiders could be deadly. Many were. The ones that weren't deadly looked almost identical to the ones that were. Snakes, same. Heights, falling meant dying. Darkness, predators lived in it. Strangers could be from a rival group. Open spaces, no cover from attack. Enclosed spaces could be a trap. In that world, the brain that survived was not the most accurate brain. It was the most cautious brain. The brain that assumed the spider was deadly and was wrong. Lost nothing, wasted a little energy, felt a little foolish. The brain that assumed the spider was harmless and was wrong didn't get to have descendants. So evolution kept the cautious brain, generation after generation, for hundreds of thousands of years, until Brain arrived, living in a climate-controlled apartment, ordering food to the door, surrounded by spiders that are statistically more afraid of Brain than Brain is of them. With the exact same amygdala that kept ancestors alive in the wild, the fear is not irrational. The fear is just installed in the wrong century. But evolution isn't the whole story, because not everyone is afraid of spiders. Not everyone panics on planes. Not everyone freezes in the dark. If fear were purely evolutionary, everyone would have the same fears. But they don't. So something else is happening. That something is called fear conditioning. The amygdala doesn't just come with pre-installed fears. It also learns new ones, and it learns them fast. Here is how it works. Brain has an experience. Something happens that is frightening, or even just startling, uncomfortable, surprising. In that moment, the amygdala takes a snapshot. Everything present in that moment gets tagged. The location, the smell, the sound, the object, the feeling. All of it gets stored with a bright red label. Potential danger. And the next time Brain encounters anything that resembles that snapshot, the amygdala fires before Brain can think, before Brain can evaluate, before Brain even knows why. This is why someone who was stung by a wasp as a child flinches at the sound of buzzing even as an adult. The event is gone. The memory might be vague, but the amygdala's snapshot is crystal clear and still active. Decades later, this is also why fears can appear to come from nowhere. Brain doesn't remember what created the original association, but the amygdala remembers. The amygdala always remembers. And there is one more way fears get locked in that Brain finds genuinely unfair. Observation. Brain doesn't even have to experience something scary. Brain just has to watch someone else react to it with fear. A parent who screamed at spiders, an older sibling who panicked in the dark, a trusted person who made it clear through their body, their reaction, their face, that this thing is dangerous. The amygdala watched. The amygdala learned. The amygdala filed it away. Brain inherited the fear without ever experiencing the threat. Brain's first instinct when afraid is to argue with the fear. This is ridiculous. There is nothing to be scared of. I'm being completely irrational. Stop. Just stop. This feels like it should work. It makes the fear worse. Here is why. When Brain notices fear and labels it as wrong, as embarrassing, as something to fix immediately, it adds a second layer of stress on top of the first. Now Brain is not just afraid of the spider. Brain is also afraid of being afraid, also judging itself for being afraid, also feeling out of control because the fear isn't stopping despite Brain's very reasonable arguments. The amygdala interprets this additional stress as confirmation. Something must really be wrong. The threat must be serious. Otherwise, why would Brain be this worked up? The self-criticism does not calm the amygdala. It feeds it. And avoidance, the other thing Brain tries, works even less. When Brain avoids the feared thing, it feels relief immediately. Relief is a reward. The brain records what produced the reward. Avoiding the thing equals relief. And the next time Brain encounters anything resembling the feared thing, avoidance becomes even more automatic, even more urgent, even harder to resist. Every time Brain avoids the thing, the fear gets bigger, more powerful, more convincing, because Brain has now spent years teaching itself that the thing is too dangerous to face. Brain cannot logic the amygdala out of fear. Brain cannot argue its way to calm. Brain cannot avoid the fear into extinction. But Brain can do something, and what works is not what Brain expected. Step 1. Stop fighting the feeling. Name it instead. When the fear hits, instead of "this is ridiculous, stop it," Brain says, "That is my amygdala. It thinks this is dangerous. It is trying to protect me. It is wrong about the threat level, but it is doing its job. This is not giving up. This is not agreeing with the fear. This is creating distance between Brain and the feeling." Neuroscience calls this affect labeling. When Brain names what it feels, "I am afraid right now," the prefrontal cortex activates. The rational brain comes online. The amygdala's response slightly reduces. Just naming it out loud changes what is happening inside Brain. Not completely, not instantly, but measurably. Step 2. Breathe out longer than you breathe in. When the amygdala fires, brain's breathing goes shallow and fast. This sends a signal. Danger confirmed. Keep the alarm on. Brain can interrupt this signal with one simple change. Breathe in for 4 counts. Breathe out for 6 to 8 counts. A long exhale activates the vagus nerve, the body's natural off switch for the stress response. This sends a direct signal to the amygdala. No actual threat detected. Stand down. The amygdala listens to the body more than it listens to thought, so brain talks to it through the body. Step 3. Stay. Don't run. This is the hardest one. When brain feels fear, every signal in the body says leave. The relief of leaving feels so good that it becomes its own trap. Instead, brain stays, even just for 30 seconds longer than it wants to. Brain lets the fear exist without obeying it, and something remarkable happens. The amygdala, when it fires, produces a surge of adrenaline. That surge has a lifespan. It peaks, and then, if brain doesn't add more stress on top of it, it drops, naturally, chemically, on its own. The fear wave passes, not because brain conquered it, because brain waited it out. And every time brain stays instead of runs, the amygdala files a new piece of data. We encountered the thing. We survived. Maybe recalibrate the threat level. This is called exposure, and it is the only thing science has found that actually rewires fear. Not knowledge, not logic, not positive thinking. Repeated survived exposure to the thing brain is afraid of. Step 4. Go slowly, very slowly. Brain does not have to start by holding the spider. Brain starts at the very edge of the fear, looking at a picture of a spider, then a video, then a spider in a jar across the room, then closer, then closer. Each step, brain stays. Each step, brain breathes. Each step, brain files new evidence. The amygdala does not update all at once. It updates one survived moment at a time. Brain is not trying to stop being afraid. Brain is trying to give the amygdala enough new evidence to slowly revise its 50,000-year-old file. Here is the part brain doesn't expect. The fear is not the problem. The fear is proof that brain's survival system works. The amygdala that fires at a harmless spider is the same amygdala that would fire if the threat were real. It is sensitive. It is fast. It is powerful. And in a world where danger is real, that is exactly what brain needs. The problem is not the fear. The problem is the mismatch. An ancient system running in a modern world. A threat detector calibrated for jungles deployed in apartments. Brain is not broken. Brain is not weak. Brain is not irrational. Brain is running hardware that is 50,000 years old, in a world that changed faster than evolution could keep up. The fear of the spider is the same mechanism that kept brain's ancestors alive. It just needs an update, not an uninstall. An update. And brain, patient, consistent, breathing, is the one who has to write it. The next time brain encounters the thing it is afraid of, the heart will still pound, the hands will still sweat, the amygdala will still scream. That part doesn't change overnight, but now brain knows what that is. Not a sign that the threat is real, not a sign that brain is broken, a signal from a very old, very dedicated, very overworked system that is just trying to keep brain alive, using information that is 50,000 years out of date. Brain can thank it. Brain can breathe. Brain can stay 1 second longer than it wants to. And somewhere in the amygdala, in that tiny almond-sized security guard who has never taken a day off, a file gets updated, one survived moment at a time. What is the thing brain is still afraid of, even though it knows better? Drop it in the comments. Brain won't judge. Brain has its own list. If this helped brain understand itself a little better, give this video a like and subscribe so brain never misses what comes next. Brain says thanks.